In this video, I'm going to go over a couple of problems from Chapter 6, starting with problem 37 from 6.1. Alright, well, we have a situation where we have a telephone pole and it's on a hill, and they're asking us to find theta, the angle of elevation of the ground, and the ground is at an incline. Okay, so let's take a look at what we have. We have a couple of triangles here that are formed. One of them is a right triangle. And I'm going to use this right triangle to figure out angle A as my first step. Alright, well, I know that if we know two of the angles, we should be able to find the third angle. And this big angle here, or the acute angle here for B is 42, and then it's a right triangle, so this is 90. And so if I add 42 to 90 and subtract it from 180, we get 48. We get that angle A is 48. Alright, so now that I've done that, I'm going to focus in on this smaller triangle. And I'm going to do law of sines to figure out one of the angles here in this smaller triangle. Anyway, so we know that angle A is 48 now, and little a is equivalent to 17, and little b is equivalent to 10. And if I'm going to figure out this angle B here by doing law of sines, so law of sines, here's the formula, and so I'm going to use sine of 48 over 17 is equal to sine of angle B over 10. Alright, so it's all set up so that I can use the law of sines, and we have only one unknown, and I'll figure out what angle B is right now. Okay, so we cross multiply. I get that 17 sine of B is equal to 10 times sine of 48. Alright, I'm trying to get B, so I'm going to isolate the sine of B by dividing by 17 both sides. Okay, now if I plug this into a calculator, I get that sine of B is equal to 0.4371. I did that calculation earlier. And in order to extract B, after all, I'm not looking at finding a sine of B, but I'm looking at finding the angle B. I have to do sine inverse. Sine inverse of 0.4371. Alright, so I plug that into the calculator, and I get an angle of 25.92 degrees. Okay, well, what we just found is this little angle here. Okay, it's not angle B it's not angle B from the right triangle, but it's angle B from the smaller triangle that sits on top. All right, so now we know that all of angle B from the right triangle is equal to 42, and since we know that the smaller b is 25.92, I'll be able to figure out theta using this equation. All right, so let's see, the whole angle there is 42, and that has to be made up by the 25.92 that we just found, and the theta on the bottom. Okay, so if I do a little bit of algebra, I realize that theta is equal to 42 degrees minus 25.92, and if I by doing that subtraction, I get 16.08 degrees, and that is theta. That's what I was looking for. This is the angle of the hill, of the ground. Okay, and so that is it for that problem.